Hello everyone, SIT210 Embedded System Development. My name is Paul and this is my 2.2 past task. So this task involved me of making a video about what you need to know in order to make the 2.1 task, which is the Morse code LED blinking project. So basically about the project is we control this particle argon right here. It take input from this push button, and whenever this button is pushed, the LED right here gonna blink your name in Morse code. Yep, so that is how it is, and now we're gonna break it down, and let's start off with the hardware and software required. So these are what the hardware and software required. Let's go through the hardware first. So first we're gonna need a particle argon, which is obviously, so right here, this is a particle argon right here. So particle argon is a microcontroller that is able to connect to the Wi-Fi or Bluetooth. It's one of the best controller for IoT out there. Yep, and next we're gonna need a push button, since we're gonna take input from the push button. So this is the push button. So this is actually what the push button looks like. We're gonna have tiny components like this. Yep, a spider looking button, and we're gonna put something on the top of it. I have a blue cap right here. Yep, just put it on. And this one I got a red cap. Yep. And next we're gonna need a micro USB to USB-A cable right there. So this is a micro USB-A. No, I mean a micro USB to USB-A cable here. USB to USB-A cable. Well, we need that cable in order to power up the particle argon, the board right here. Yeah, we need power supply for this one specifically. So that's why we need the cable. And finally, we're gonna need Wi-Fi enabled device like laptop or smartphone. Well, the reason we're gonna need that because this particle argon require internet connection through this antenna right here. Is gonna use this antenna to connect to your any Wi-Fi or your personal hotspot, and the one important thing about that is it can only work with 2.4 gigahertz band antenna. I mean this antenna is only work with 2.4 gigahertz band network, which means if you're using a Wi-Fi or a personal hotspot, you gotta make sure that it is a 2.4 gigahertz, not a 5 gigahertz, because you can't find it in the Wi-Fi list. Yep, so that is one very important knowledge, very important notice. So back again, we need particle argon, push button, micro USB, and Wi-Fi enabled device. So we got particle argon, micro USB. This micro USB cable will come with the particle argon. So in case if you don't have one, then you just need to purchase a USB to a micro USB port. Yep. And finally is the Wi-Fi enabling device. I will use my phone as my personal hotspot and make this particle argon to connect to that hotspot. Yep. And for the software required, we're gonna need web browser particle IDE. So web browser particle IDE is is something like this. Yeah, it's gonna be something like this. So in order to find this, first you need to download an app on your phone. It is called Particle IoT. After you have downloaded that app, you will be taken up to the setup phases where you're gonna create an account or log into your existing accounts, and then you're gonna add a new device by scanning this this QR code right here. Yep, by scanning this QR code, gonna add your device, and then it's gonna take you to the internet connection spaces where you need to connect this particle argon into any internet connection, like a mobile hotspot or a Wi-Fi connection. Yep. So in order to do that, all you need to do is just to connect to download the particle argon IoT particle IoT. I apologize, particle IoT. the app in your phone, and then just create an account and scan this QR code right here to add the device, and then we're gonna take you through a Wi-Fi registering steps. And yep, this is gonna be really easy, and once everything is done, you are ready to go. And about the web browser particle IDE, we have here we have the link. We have the link of the particle attached in this. You can, or you can just go online and search for particle web IDE, and it's gonna take you to somewhere like this, where you need to log in into your accounts and just upload the code into it. But we'll break it down later. So that is all of the requirements of hardware requirement and software requirements of this project. Now we're gonna go through the goal, the target of what we actually need to do in this project. So it is saying that, so say we have a particle argon with a built-in LED light. Yep. So the particle argon has its built-in LED light. I'll show you. Here, you see the LED light is blinking right here. This is the built-in LED light of the particle argon. Yep, it's blinking right there. Yeah, so every particle argon has that built-in LED light, and we need the LED light to blink our first name in Morse code when a push button is pressed, which exactly mean like this. We need this light here, or this built-in light to blink our first name in Morse code once we press a push button like this. Yep. And one more thing is we also need the system to reset and then start blinking the name from the beginning when the push button is pressed again, which mean if we reset this particle argon, we reset this board. Oh, and I'll show you how to reset it. There is a tiny button right here, a tiny physical button right here. It's saying reset under it. Here, if you can see, it's right there. So you press this one, press it, and yep, if it's showing like green light blinking like this, it means it is resetting. It is finding a stable hotspot or connection to connect to that connection, and it'll be ready to go. Yeah, so the goal is the device need to be able to work again once it's reset. So yeah, so that's it. And now we're gonna go through the whole process from beginning. So once you open the particle IDE, you need to search for an example first to have a clear example of of like how to make everything from scratch. So you have to look for this panel right here, this whole panel, and then click for this icon specifically, or the code icon. There, just click in that. And then you scroll down, and then you're gonna find some example apps. They have 6 examples right there. You can look for let's say take the first one, because that is what we need to blink a LED. Okay, so that's it. So you click on that, and it's gonna take you to the code file of the LED blinking sketch. So I'll explain to you everything that's happening in this code file. So, oh wait, but before we go into this code, let me explain you about the wiring and the electronic components in this circuit. So okay, so I apologize for my device is blinking green because I'm using a personal hotspot, and it's not really stable when I'm filming the video. It's not really stable, but yeah, blinking green is searching for a hotspot connection. But since I'm using my phone to multitask into video and all that, so I guess it's unable to find the hotspot, my hotspot back then, or it got turned off accidentally. Yep, but that's not a problem. So what we need to do is we need to set up the circuits. So there are two components that we need to notice is the push button and the light, the LED light. So let's go through the light first. So in order to set up the light first, we need to initial the pin. The pin is like we have a lot of pin on the two side of the board, and you can see we have D8 in here, D7, D6, D5, D4, and then in this side we got A5, A4, A3, A4. A is for analog and D is for digital pin. So so in order to wire this light, we need a voltage in a ground wiring. So first we're gonna wire pin 7, because you know as is stated in the code that the LED so this light gonna be controlled by the pin D7. We can set it to any pin we want, but I'm setting to pin D7. Yeah, so this light gonna be controlled by pin D7, and the push button gonna be controlled by pin D3. Well, you have to initialize, you have to define the pin that you're gonna use in your project. That is one of the first steps you have to do, because that is really important. Because by defining the pin, you gotta adjust the code to control those pin. And if you don't define the pin, or you define it wrong, then the particle argon will have will like have no idea what is it working with. If you're like, say, if you're wiring your LED light to pin D7, but you don't initialize it, you don't say the LED light is in pin D7, or you don't, or you say it in pin D6 in the code. So in the case you say it's pin D6 in the code, the particle argon will control pin D6 instead. And in the case when you forgot to initialize pin D7, there will be an error showing up on the IDE. But that's just something you need to keep in mind, because to be able to control any electronic components in the circuits with these microcontroller board, the first thing is you have to define which pin they are using. Yep, because there are many pins, and you have to define what pin they are using at first. Yep, so like I have said, let's go through the small LED light here first. This small LED gonna be powered by pin D7. So I wired a resistor from pin D7 right here. Let me zoom in for you guys. I'm sorry, it's a bit blurry here. So it's coming from pin D7, and it's come all the way to this right here, which is the longer leg, which is the voltage in leg of the LED. Yep. And I forgot to introduce you these two. So these two wires are the ground and the 3.3 volts. So they're all connected to these two plus and minus symbol right there, which is like the black wires right here is the ground, and the orange one is the 3.3 volts. So by connecting those two wires from this, which mean they're gonna take 3.3 volts and ground from the microcontroller, and they're gonna pass that like, for example, this orange wire is 3.3 volts. Then this whole red, the whole line of like this whole line, yep, this whole line from the top to bottom in the plus, the positive symbol right here, the plus symbol, is gonna be 3.3 volts. And the black one, I mean, it's a wire from all the way there to here, which means all of the the line in negative symbol, in minus symbol, is gonna be ground. So an LED, like, let me take an example here. An LED, we have a longer leg and a shorter leg. The shadow's making it confusing. Here, let me hold it up. Yep. So as you can see, there is a longer leg and a shorter leg. Here. So this is a longer leg and the other one is the shorter leg. So the longer leg is the one that we need to be connected to the 3.3 volts or any voltage in volts. And the shorter leg is the ground, or the ground one. Yeah. So this is the similar of what happened. So take a look of this LED. I will just take it out. Yep. So it also has, this one is the long leg and the other one is a shorter leg. So I plug it right in there. I plug the long leg right after the resistor, and the shorter leg right in the minus line, like the ground line. Yep. So and the resistor, I wired the resistor from D7 to the positive leg of this LED. The reason I use the resistor is that resistor can prevent any over voltage flow in your circuits, which will lead to like damage of the electronics components, or in more severe case can even lead to explosion of your circuits. So it's always safe to use resistor. Yep. So that's just the wiring of the LED. Now is the wiring of this push button. So similar to the LED, this push button gonna take input from pin D3, which means we're gonna wire pin D3 to the negative pin. No, I mean the positive pin, the voltage pin, the voltage input pin of this push button, and the negative pin of it, which is this one, the ground pin, is gonna go straight to the ground line. So once again, the minus symbol and all of the simple pin, like going all the way up there, it is the ground, and the plus symbol right here is all of them is our 3.3 voltage, 3.2 voltage. Yep. So that's it for the wiring. I'll go through everything once again. So this LED right here gonna be controlled by pin D7. We're gonna state it in the code later, but this is just the wiring, because we need a wire from D7 to the longer leg of this LED. Yep, I'm using a resistor. You need to use a resistor, or in this case, if you're not using a resistor, it's also gonna work, because this is just a small light. Yep. But so you're wiring the D7 to the LED, and the shorter leg of the LED have to go with the ground. Yep. And for the push button, since we're wiring is to pin D3, so we need to wire D3 to the positive pin, the volt pin of this push button, and the ground pin is gonna just go straight to the ground. Yep, that's it for the wiring. And now I'm gonna explain the code a little bit. So this is like I show you, this is the example code. You can find it right here. Just click on this code symbol. Yep. And open the blink and LED code. Yep. So this is it. This is what that blink and LED code look like. So first of all, like what I've said before, in this example, they're using two LED 1 and LED 2, and they are defining it in two different pin D0 and pin D7. Yep. These are one of the most important thing that you have to do in the beginning of your code, is to define the pin of your electronic components. If you're using a LED, so make sure you have to define it in the corresponding pin port that you're using in particle argon. So int LED 1 equal to 0 and int LED 2 equal to 7, which means they have two LED wiring to pin D0 and D7 inside into this particular argon. Yep, so that's it. So in the setup phases is where you're gonna specify these LED as output or input. So the LED, so the difference is if your output is mean these, let's make it easy. Output, when you set something like pin mode LED output, so this output right here, which means the LED does not do anything. It just take command from this board, from this particular argon. It just take command from this to be whether to be turned on or off. So output mean that the electronic is like something that keep waiting to take command from this particular argon. Yep. So once again, output mean that it's waiting for command. It does not do anything. It cannot give command back to this one. It's just sitting there and waiting. If this big board right here telling it what to do, then that's it, output. Yep. And input, in the case where we need input, which we're gonna use later. So this push button right here use input, which means it's gonna give command to the board. Yep, which means the board gonna need command, gonna need signal from this push button. So we're gonna specify that input. We're gonna go through that later. Yep, so that is what these two lines of code mean. Pin mode LED 1, LED 2 output, and that we set both of the LED to be output mode. And the loop mode, oh, I forgot to explain you about the setup. The setup function is what you declare what need to be noticed, and is only run once. And the loop is what gonna run like forever, since it's named loop, right? So in this loop code, they have digital write LED 1 high. So this is the code that this line of code mean that the LED's gonna turn on. Digital write LED high, which means the LED's gonna turn on, it's gonna light up. And then you delay for 1,000, which means this 1,000 number is in milliseconds. So you are delaying the LED on for 1 second, and then we turn it off by just running digital write LED. The same thing with this, but change high to low, and which means it's gonna turn both of the LED low, which means it's gonna turn them off and wait for 1 second. Remember, these numbers are in milliseconds. Convert to second, it's just 1 second. 1,000 millisecond equal 1 second. Yep. So now there's a few things that we're gonna need to adjust the code to make the Morse code program. Oh my bad. I will open the Morse code program of mine and show you what we need to do. Okay, so before we go into everything, let's just have a brief understanding of what basic Morse code is. So this is Morse code right here. Morse code is a signal code for every letter in the alphabet and letter and digit. And so this one right here is the International Morse. You can find the link to this website right in the it's right here, this link right here. Yep, you can find the link, and this is where you're gonna take you to. So what I'm saying, this example is kind of hard for you to imagine, so I have an easier example for you right here. Yep, see that? So as you can see, every letter or every number, but right now we're just working with letters, so don't notice the number. So every letter in the alphabet come with some random signals like this. We're gonna understand it later, but let's have a look of the letter A. It has a dot and a dash, right? It has a dot and a dash, which means in the Morse code, the dot is for you're gonna blink this LED for a short duration, and the dash you're gonna blink it for a longer duration. So let me convert these into sound signal so you can have an easier or better understanding. So letter A, we have a dot and a dash. It's gonna be like this. So I will demonstrate you in my voice, and I'll say dot is like beep, and then dash is beep. Yep, it's a bit longer. So letter A gonna be beep beep. Yep, similar to letter B, it's gonna be beep 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 beep. Yep, it's like that. I hope you get a better understanding of it. So letter C gonna be beep 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 beep. Yep. Letter D gonna be beep beep beep. Yep, that's it. So you have a dash and a dot, and each of them just have different in duration. That is what a sound signal is, and for the Morse code, they usually display it in the like yeah. So in this project, we're gonna blink the LED to have it like blinking in a short or a long duration, and it's gonna blink our name in Morse code. So about the timing, let's go through a bit of the timing. The first thing actually is we need to define the LED and the push button pin. Like what I've said before, I'm using the LED at pin 7 and the push button at pin 3. Pin D3 and D7. So I need to define that the LED I'm using is pin D7, and the button is pin D3, and the button state is just a temporary variable that I use to check for button status. Yeah. So next we define the duration of the signal. Yeah, that's what I've said before. So in the Morse code timing the international Morse code timing, we have dit is 1 unit. Dit is the dot, like this one. This one is dit, and the other one is dash. Da, I mean, yeah. Oh. So we have dit will be 1 unit, and da gonna be 3 units. So in the code, I have the dit duration set for 100 millisecond, and the da duration set for 300 millisecond, according to these information, 1 and 3 units. And so I have it for 100 millisecond and 300 millisecond. And then we need the break between each letter and each word for people to understand. Yeah. So there are two type of breaks between so we have difference between the first one is called intra character space. Let me zoom in a bit for you. Intra character space. Yeah, there we go. Intra character space is the gap between dits and dash within a character, and it is account for 1 unit. And then the inter character space, the gap between the character of the word, it's account for 3 units, and the word space will be 7 units. That's the longest word space. I mean the space between two words. So I have it all set it in this code. Oh, let me like that. Yep, I got the intra character duration. It's blurry here. Intra character duration for 100, inter character duration for 300, and space duration for 700. So basically I have every here 1 1 3 7 there 1 3 7. So basically I have I have the duration set up exactly like the international Morse code. So but I'm using it in millisecond. Yep. So you're gonna see that's why you're seeing my the LED blink at the really kind of fast rate, but that is the actual rate that I use with the Morse code timing. So the next thing is the small variable here. We're gonna state our name. We're gonna store our name in the variable name. Yep, string is the data type of that variable. So my name is Paul. I gotta store it in the variable name. Coming up after that is the whole array. I mean the list of every character from A to Z in the alphabet in Morse code. So say example, the letter A you're seeing in here. The letter A is a dot and a dash, right? The letter A in the Morse code is a dot and a dash. So that's similar to what I have in here. Letter A, I have a dot and a dash. Letter B is a dash, dot, dot, dot. B, dash, dot, dot, dot. Yeah, I have every letter stored in a list, all of the letter from A to Z inside the alphabet. Where the reason I'm doing this is for the reusable of my code, since if you make every letter manually, then in case you need to make, in case you need to display a new message or you got a new name to blink, then you gotta make the whole letter. You gotta go up to the internet, search up the Morse code for that specific letter, and just work on it all over again. It's gonna take you a lot of time. By doing this, gonna save you a lot of time. I'll go to break into it later. Yep. So the setup function, similar to what I've said before, setup function is where you define whether the electronic components of your circuit is an output or an input. So right here, I got a LED as an output because the LED doesn't take any input. It doesn't give any command to the board, but instead it take command from this particle argon. This particle argon gonna command this LED to whether it be turning on or off. That is why the LED is set to output. So the pin mode of the button gonna be input because the button gonna give signal to this particle argon. Yeah, so once we, because the button is made for pressing, right? So this particle argon need to read the status of this push button, whether it is being pressed or not. And if it is pressed, then this particle argon should know that, and it should perform something if the button is pressed. Yep, so that's why we set it as input. Once again, output, listen for command, and input, give command, the easiest one. Yep. So in the void, in the loop function, that is what happened in the setup function. Just 2 lines of code. That's it. In the loop function, it's kind of long. I'll keep you looking at. I'll keep my phone looking at that while I'm explaining it for you. Everything that happened in this loop function. So the project requires that we need to create a push button, and whenever the push button is pressed, the Morse code light's gonna blink. The light's gonna blink in your name in Morse code. So first we have to, we have this very first line of code in the loop function, say the button state equal digital read button. So once you put everything in the loop function, they're gonna run again. Yeah. So this means the board will continuously again listening for signal from this push button, and this is what the code of making the board to listen to the signal from the push button. Digital read button mean that it's gonna read signal from the push button, and it will know whether the button is being pressed or not. This is the if the button is if button state is low, which means the button is pressed. Yeah, that says it's low. So the button state digital read button is to make the board continuously reading signal from the button. And if the button is pressed, which means it will know because it's continuously reading signal. And if it read that the signal from the button is low, which means it is pressed, then it will start on working on blinking the name in Morse code. So I'll explain the code behind the whole converting the name into the Morse code signal and display it by the LED. So first I have to convert the name into lowercase. Yeah, I have to convert it into lowercase because we don't want to mess around with uppercase and lowercase letter in case there are many things going on. Like I'm having my name with a capital P. Yep. And here capital P right there. And once we put it in, so this name gonna convert all my name to lowercase. Yep. So before I go deeper, let me just briefly notes you about what what this code actually do. So it's gonna break down my name. It's gonna, like, my name is Paul. Let me show you up there. My name is Paul. So it's gonna break down my name into 4 letters, and then it's gonna convert them into lowercase letter, and it's gonna look up those letters in this list. Yep, for example, the letter P is gonna be somewhere right here. Yep, it's gonna be a dash, 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 dot. Yep, it's gonna look up the every letter of my name in the list, and if it's got the Morse code symbol for that letter, it's gonna control the light to blink accordingly. Yep, so that is the concept behind this. I'll go through every single line of code for you to easier to understand. So first of all, we need to convert the name into lowercase, all lowercase letter. Yep, and then we iterate through every letter in the name. We iterate every letter in the name, and then we look for that specific letter in the Morse code list here. Like I've said, for example, the letter A is gonna be one right here. Yep. Yep, that's it. So so this for loop is just a for loop. It's keep looping. So if my name have 4 letters, so it will loop for 4 times because it's keep looping at every letter in my name. So the char C equal name char at Y, which means C will be equal the letter at the destination for. If I is 1, then the letter gonna be A, because the second letter of my name is A, since it's all start from array. Let's start from 0. Yep. And if the C is blank, I mean there's a space, which means that is the letter between that is a space between 2 words. But we don't have that case in this project, because all we display is our name. Well, but but like if you're having a name that it has space between, like your name come up with multiple words, or in case you want to display any message or anything, then it's also fine if you are using this code. I mean, yeah, if you got space between the letter, between the word, and then it's gonna delay in the break duration. Remember what I showed you before? Here, right here, word space, yep, equals 7 units, which means this is the word space. This blank spot right here is a word space. And if there is a word space in the message in my name, then it's gonna delay for space duration, and space duration equals 700. Right here. Yep. That's it. And if it's not a space, mean that it must be letter. So if it is letter, then we'll need to search up that letter in the list of Morse code. Yep. And so the first line of code is like, for example, if the letter is B, then B minus A gonna be 1, and like C minus A gonna be 2, or D minus A gonna be 3, and it just use that index to index the specific letter in this array. Yep. And if the symbol is a dot, mean that it's gonna control the LED light will blink in the dot duration. Oh, and dot in like I've said before, dot is dit and dash is da. So if the symbol is dot, mean that the LED's gonna be high for a dot duration, which is 1 unit, 100 millisecond, and then it's gonna turn off, and it's gonna pause in intra-character duration. And if the symbol is the dash, And then the LED's also going to turn high, but it's going to remain high for a DA duration, which is 300 milliseconds. And then it's going to turn off, and then it's going to delay for an intra-character duration. Intra-character duration is 100 milliseconds. That is the duration between the two letter. Yep. And then it's gonna delay for an inter-character duration. Yeah, and yep, and that's it for the whole thing. Let me go through everything again. First, you have to define the pin of your your electronic components in the circuits that is connected to the particle argon microcontroller. You gotta define them, and then you gotta define every necessary variable. Like in this one, since we're controlling the LED to blink in Morse code, the timing is the necessary variable that we need to keep track of. So yep, keep track of, so define the timing, the duration, all the duration of how long will the LED remaining on and off. And then you display the name. This can be replaced by your name, or in fact, as a matter of fact, it doesn't have to be a name. It can be any message, like say hello world, or I love ice cream, or I am stuck, or need help, something like that. Just replace all of that in this string. It's gonna display it in Morse code. Yeah, and then for the effective and easy and usable of the code, I make a whole list of what every single letter in the Morse code of them in the alphabet. And for the code, because my code is made to search, to look up all of the letter, that means it's gonna be reusable. Which means if my name is not Paul, if my name is Henry, it's gonna look for HEN RY letter in this area, in this list, and it's gonna just display it. It's gonna just blink the letter accordingly. Yeah, all you need to do is just to change this string name right here. And setup function, you put the you define the LED or the button as output or input. So we have the LED as output and the button as input. Yep. So next thing, what's going on in the loop? Say it once again. What's going on in the loop is that I will first first is listen reading from the button, and then if the button is pressed, then I'm gonna lowercase my name, lowercase lowercase my name, and then like slice every letter in my name, slice them out, and then put them, and then convert them into Morse code. Yep, and then convert each of them, all of them, into Morse code one by one, and then display the Morse code symbol in the LED light. Yeah. Yep. That means if my letter is Paul, so is the letter P is right here, is the dot dash dash dot. So so it's gonna slice my name. It's gonna take the letter B. It's look up in the list, and if and once it's got a letter B, it's a dot dash dash dot. It's gonna go through every symbol one by one. So the first one is dot, so it's gonna be dot. The LED gonna remain on for 100 millisecond, and then off. And then the next one is dash dash dot, which means dash is gonna remain on 300 millisecond and then off. Yep, and just keep going like that for the rest of the letters. So I have explained everything's going on with my code. So once you have done your code like this, come back to the circuits. These are the things that you need to make sure. First, always wires the particle argon. You need to see it's like blinking. Yeah, and then make sure your electronic components is all wired up safely. You got resistor, or everything is all it's all safety. And then third thing is make sure you stick this Wi-Fi antenna, because the argon need the antenna to connect to the internet, because you're gonna upload this code Yeah, and then it's gonna upload it to the cloud, and then this particle argon gonna retrieve that code from the cloud to perform your specific task that you may program it to do. Yeah, so once you have done with everything, you need to press this lightning button right here. It is the flash button. So what it does, you pressed it, yep, you pressed it, and then it's gonna say flashing code, and then it's gonna successfully flash the code. Uh, yeah, it's gonna flash the code, and it's gonna say so in my case at the moment, I don't have the Wi-Fi hotspot because I'm using my phone to record the video, so the hotspot is not stable. But this is the phase when it's coming to an end. You just make sure that your particle argon have a stable internet connection. Then you press the flash button, and then this particle argon, once mine one is still blinking green because there's no internet connection. But if you got a stable connection, you're watching this video, you're using your phone as a hotspot, or you got a stable internet connection, then this light gonna be in blue, not in green like mine. It's like gonna be in blue, and then when it's blinking slowly, and that's mean the code is successfully uploaded. And you can also find a message in here. Yep, it's gonna be successfully uploaded, and everything is ready to go. Yep, so it's what you need to know in the Morse code blinking project 2.2. Yeah, thank you for listening, and have a good day.